Chapter. We have three major chapters left to do in the limited time that we have left. So I'll let us finish this one, which will only take moments. So this is where, remember, this is where we left off. Reportable diseases. My whole big spiel about don't lose your license. Don't do that. Okay. It's reportable. It's reportable. You're going to run in. These are the kinds of things in professional healthcare for those going in there. And most people think you run into all those things where you have to put. There's a fine line between your personal feelings and your professional behavior. Not easy. It's one of the hardest lines I had. I was too emotionally invested in patients, and you have to be somewhat objective. By the same token, from that perspective, and I'm being very preachy about it, but it's when you see child abuse or neglect, when you see diseases that should be reported or not, when there's obviously a sick, how you do that professionally you're going to get that through tincture of time. It's going to take some time to sort of figure out how you best approach, how you speak to people. It ain't easy. It's not easy, everybody, to do that. I'm telling you now. I mean, there's all sorts of things. So there's a certain amount of teaching and learning that's involved. So that's it. But look at these. I mean, there's a lot of diseases here, and you're going to run into them. I mean, so it depends on where you are. There's just some of these are just. I had one of these. I'm sitting there on the phone when I had salmonella with the county health service. I mean, it's an interrogation, but it's what you have to do. They had to report that it. Obviously, I ended up being admitted in ICU at St. Margaret's in Aspinwall, big hospital. What they got to do. So all of these things, and really, we're just seeing it now. When we begin to see things like that or begin to rear their ugly head, it's the only way the authorities can get a handle on it. And that's their job. Okay. So and now these are definitional terms. And there'll be a few of these. Okay. Prevalence is the total number of cases. It's a snapshot of how many people got it. It doesn't tell you what stage. Did they just get it? Are they recovering? Are they really sick? Are they getting better? Are they just starting to feel it? Total number of persons in a population times 100 equals percent. So again, at present, 14, currently and at present are different terms. I digress. Okay, so let's say that gives you an idea. Are they smoking heavily? Did they stop smoking? Not that, but so prevalence is a useful term. It gives you sort of a global picture. Incidence is a very interesting term because that's when you begin to see if these things are starting to, how severe they are. So the number of new cases over a certain period of time. So in a designated time period, divided by the total number of susceptible persons, usually reported per 100,000. So new tuberculosis cases in the United States, 2018, gives you an idea that most of this data is 6-7 years old, 2.8 per 100,000. And they look at this. Are we getting a handle on it? Is the next time, if they looked at this, if this was the next time they publish this textbook, let's say the data is from 2023, 5 years, effectively contemporaneous data with right now, and it says 3.2, we're going the wrong direction. But incidence, when you're wondering what an epidemic is, okay, that's when we start to look at these features. We have an idea what the incidence should be of a particular disease. Take the flu, would be a perfect example. We know that we just got really effectively past flu season, there's an anticipated number of cases per 100,000. They're going to be reported. Again, we know that not everything is reported about it. But for the ones that were reported, we can sort of discern what the number is going to be. It's been around for a long time. It's nothing new under the sun here. But what happens is, at that point, we can tell whether there's going to be, so if it's greater than anticipated, that's an epidemic. It could be a greater than everybody. Oh my God, there's an epidemic. Vis-a-vis COVID and whatever, how many variants we're going to have, or monkeypox. Okay, it doesn't comment as to severity. It's a statistical measure to identify more cases than would have been anticipated at this particular time in this particular geographic region. Okay, we could have an ingrown toenail epidemic. Oh my God, stop the press. So people, it's like they say pandemic. Oh my God, we're dying here. Let's close everything down. And that's what bothers me about these things. Was it a pandemic? I mean, pandemic means across the continent, okay, across a big body of water, like an ocean. That's all it means. HIV/AIDS is it's here. It's part of it. It's still considered a pandemic. Okay, does it mean we're all sitting there frightened to death and not going out of our houses? No. So words matter in the sense that they're buzzwords. And today, years ago, you would be listening to it on the news. Now, I mean, it's instantaneous. Okay, and we have to learn to not respond instantaneously, I think. So statistics of concerns, epidemiology are rates of disease, rates important. Not so much that prevalence is noteworthy, but the incidence rate, very, very important. And again, all of these different factors are involved. Mortality and morbidity don't mean the same thing. Mortality is very obvious, death. Morbidity means, okay, although the number of persons afflicted with this, morbidity rate has remained high. So what does that mean? Mortality and morbidity are not the same. Morbidity is number of people effectively getting sick. It doesn't necessarily measure how sick, and mortality means dying. And you're going to see in the hospital, one of the things you might be invited to or to attend, because they're held monthly, is called morbidity and mortality rounds. I mean, everybody who dies, imagine everybody who's admitted and has not survived, or we have a significant number of illnesses discussed on a monthly basis, and doctors and nurses and infection disease control people and all of those, and you might be sitting in on that. That's what happens in the hospital. They're constantly looking at that. Those are important numbers. Those are things for the hospital to remain accredited. So you have to know there's a certain, I wouldn't call it so much a business aspect, but a documentation and compliance aspect with various governing bodies. You have Medicare, you have Medicaid, you have the state, you have the federal government. It all matters. So if you're going to go into the system, be aware of what the system it is. Okay, and the same would apply, since we have perspective here, military-wise. A whole different level of stuff like that. Right? All those things. So yeah, whatever your playing field is, you better be familiar with how deep center field is, how high the fence is in left field, to use baseball analogies or whatever. Okay, so, and then we look different kinds of data. Number of measles cases reported by year. And you get, talk about vaccine. And now we're really seeing, I imagine this chart now in the next edition of this textbook, if it encompasses this year, it's going to be way up here. So for people, and you'll hear that, measles does kill. We're going to get to that in respiratory diseases, or skin diseases rather, relatively soon. Okay, number of lung injury cases reported to CDC as of November 2019. And you begin to look where there's not, okay? Does that say lung injury? It's hard for me to read from here. You can see where it's darker. Why would it be in particular? I wouldn't even begin to speculate. Lung injury cases. I mean, I can understand in desert Southwest, we have a lot of airborne fungi. Don't know. So, a common exposure to a single source of infection. These are the kinds of things where we're looking. These are some terms I wouldn't even get into or ask you about. I'm just reading them to you. Okay. So a common exposure to a single source of contaminated water, a point source. Let's say if you want to accept that COVID started in that market or in that lab, that's a point source. And say, and now when it's propagated, it means it really progresses. And that would be maybe another example of COVID. It's communicable from person to person, sustained over time in a population. I'm not going to ask you any of those definitions. They're relatively new definitions. But the idea is it's some common sources of problem. Water, particularly water supply, food supply. And I get I'm on what, I like to cook. So I'm constantly getting email from allrecipes.com. Okay. And every time there's a food recall, it's on there. Keep an eye on those. I mean, it's not like they've come at Aldi's, they've come at Walmart. Be aware of that stuff. If not anything else for you and your family. And so now they begin to look at some of these curves. They'll give you, I won't even bother to. I mean, you see these certain areas where we see outbreaks at particular points in time. So I'm not getting a lot out of those curves. I'm not going to ask you about it. Did you do the synthetic epidemic in Dr. Dress's lab? We're doing it in my lab. Hey, you're all welcome. I'll be glad to infect all of you.
Our syllabus next week, I think.
Oh, you're doing it? My favorite experiment. Because all we do is we spike a little test tube of water with a chemical that when we have enough of it in that test tube and basically you take pipettes, disposable pipettes, and basically cross-contain, you're having a fluid-borne illness. That's right for not being careful, if you get the idea. No, I'm not pointing at you.
You did.
I just wondered what you're having to drink.
Coffee.
Just no latte, no one-shot espresso, French vanilla, of course. So that's one of my go-tos. Okay. So in that lab, we demonstrate, and the goal of the lab is we typically, let's say I used to do it with 2 students, but we have 1 student, it's a blind, so I'll put down what tube I spiked, I'll write it on a piece of paper, I'll stuff it someplace where nobody can see it, and then we endeavor by backtracking to figure out who the index patient was. If you want to go back and there's a movie called Contagion, maybe you saw it with Matt Damon and stuff like that. Did a very good job about showing the whole ballgame was when can we get to the index patient. And Matt Damon's wife, who was, let's say, whoever that was that Gwyneth Paltrow, I think, was a little bit frisky, if you know what I mean, when she was on the job. That didn't help the marriage any, but what happened is it helped spread the disease. And they were able to identify when she was in her travels somewhere in Asia, that eventually they backtracked and found. And that's the only way you've got to find out who those carriers are to find out what the disease, so you have a chance at formulating a vaccine or a treatment for it. So that's the whole ballgame is index patient. If you have, just like we talked about before, one of these, what's the terminology, a point source. So you're going to look for the first epidemiology, and they have it in the other PowerPoint from the other textbook, from the Nestor textbook that I like. It involved a water supply in England in the 1850s. It was really the first time when everybody was drawing water from the same common water supply. And that water supply was contaminated with something like cholera. And explain it was one of the first tracings. Endemic, relatively steady, long period of time. Lord knows, we're endemic with measles would be endemic. Whether or not we have immunization, whether people are immunized or not, or don't choose to be, another issue entirely. The measles is always here. And common colds are always here. These are things you can't do with, so it's endemic. Okay? Flu viruses during certain periods of time, they're just always going to be here. Sporadic means occasionally we'll get certain hits epidemiologically. And for people going into public health this way, we got a case here and a case here and a case here. There's no real pattern to it. That's sporadic. Okay. And here, when statistics indicate that the prevalence, number of people affected, of an endemic or sporadic disease is increasing beyond what would be expected for a population. So this goes back for a lot of times with statistics. Statistics is on the nursing, right? Did you guys have that yet?
Not yet.
Yeah. The reason it's important for nursing is because when you're in a BSN program, you have to look at research studies. And you have to understand what standard deviations are, what's statistically significant, whether you use a chi-square or a t-test, because maybe you're going to be doing your own research. I know my ex, that was when they had to do an original research project, and she and her colleague, who came from right around here, this neck of the woods, her kids went to Moon High School, subsequently found out. They did it on something called primary nursing, So I do not know if it's still in vogue or anything like that. And they had a questionnaire, we call it a Likert scale. You see it all the time. You're neutral about it, liked it somewhat, liked it a lot, didn't like it a lot. That's a Likert scale, that 1 through 5. And then they had to analyze the data. They had to do the write up, determine whether it was statistically significant, determine whether it was just what we call inferential data. In other words, what inferences can we draw from this? It suggests that this was a good form of nursing or I don't recall. I typed the whole thing up. It's handy. And I didn't even get an A in the course. They did. I don't know. She was the directress of nursing when they used to have a nursing, this other gal over when Swickley Hospital had a nursing school. She was when I met up with her, she was assistant director of private cancer, but they closed the school pretty soon. Nice gal. Nevertheless, that's the whole idea. And pandemic, cross continent, cross an ocean. So understand what the terminology means. So terms I think you'll see: index case, endemic, sporadic, epidemic, pandemic. None of these speak to the severity of the disease. If it has a high mortality rate or a high morbidity rate, and symptoms or signs and symptoms are severe, okay, now you're talking about a very serious ailment. Okay, so it's far too soon to report on definitive whatever those and that is for SARS-CoV-2. I don't know what it is, so I'm not going to ask you. So it seems to be very communicable with a relatively low case fatality rate. And I'll buy that. What has happened over time, for most of us who look at this stuff, and I get articles, it's from the Journal of New England Journal of Medicine, and anybody can sign up. And you can read little abstracts of articles without having to buy the publication. It's talk about for 5 years, all we do is read about COVID. But effectively, what a lot of people figured, COVID would start severe, and as it began to, what happens is it begins to mutate. It typically becomes relatively communicable, even more communicable, but less problematic. It's not that viruses are living, but they do the same that living things are. They don't want to kill off the population that allows them to survive, if you want to think of it that way. There's sort of a balance with regard to disease that we see. See, why do you need all this stuff? I don't know. It's in the curriculum. That's why it's here. But you do have to, the whole chapter about this was how diseases spread. Okay, and what kind of damage they do. So to me, it's I will not get to it today. I will undoubtedly have to find an amount of time over the weekend. Again, we have the baby shower. Do you know how much that crib set weighed? Did I tell you?
Did you say 100 pounds?
What?
Didn't you say 150
Yes, and it
pounds?
did. I got back Wednesday. I pulled into the driveway. My wife was going to with our buddy going out cake shopping because he can hardly get around. And oh my God, this giant, it's like a big flat giant box on the driveway, and it's going to start to rain. I have to wait till she gets home so we can lift it and slide it. It's 150 pounds. We're not young anymore. So anybody would like helping me Saturday or Sunday, lighting it into my van, we'll find a way to get it. To get that there. Oh, my us. Okay, new unit. End of that, start of the final unit. Are you ready? Yes. I'm happy to hear that. To that end, we will proceed. So we'll come back to here and show, where did I go? Here I am. Content. And I'll change this obviously to unit 4, but here you go. Look what I have for you just to start. Respiratory disease, we'll do first. This is from textbook. Then skin. Chapter numbers are a little different here. I actually have respiratory disease notes and skin disease notes. You don't have to thank me again. Just send. Joking. You never can tell. People are listening. So here we are, chapter 19. I will also undoubtedly use some information from the Nestor PowerPoint because they don't all cover the same things the same way. Is I guess the best way to describe it to you. And so here we are. Okay, blah, 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 blah. Okay. In A&P, we're doing respiratory. Nearly all of you have me for A&P. Okay, so we've done this, not going through it. So again, upper and lower, the most common diagnosis in the world is upper respiratory infections. At least it dovetailed nicely the way we're teaching it. Lower, effectively below the larynx. I'll buy that. Again, if you start with laryngitis and it meanders its way into pneumonia, then to me that's really a lower respiratory infection. And then all the anatomical structures that are there, and the same. And again, the two, without going crazy over it, the two big features, the anatomical bases of the disease. Big point I made in anatomy and physiology. Okay, the right main bronchus is much more vertical. The left, much more horizontal. It's got to go over the heart. Most pneumonia, okay, which basically are particles vis-a-vis gravity coming down through the trachea. Where are they going to go? Most likely they're going to go to the right. It's a wider tube to start with. So that's an anatomical basis for disease. That's important. The other anatomical basis for disease is up here. There's a little overlap in this textbook. They include things like conjunctivitis with skin. I do not. I do conjunctivitis. I think conjunctivitis has more of a respiratory relationship, so it has some skin related sort of an overlap. But the big deal about that is the ear. As common as any infection in from babies up until roughly age 4 is middle ear infection. Otitis, inflamed ear, media, middle. Okay, it all has to do with that eustachian tube. Okay, the eustachian tube in you and I is angled down. Okay, as we, over those first 2 to 4 years, and it varies, some kids are more prone to it than others for any variety of reasons. As the baby begins to physically elongate, that tube initially at birth is like this. It's almost completely horizontal. So when the baby sleeps, boom, any yuck that's coming from their nose is going right back to the middle ear. So why do we see them dissipate 2 to 4 years? Because that is going from mostly horizontal to fairly vertical. And now when they're sleeping, it's not likely to do that. You and I get a thing called a postnasal drip. So it comes down, but really it's going into your throat, and sometimes you'll wake up with it. I mean, I'm sure many of you had ear infections. Probably some of you had tubes in your ears, just like my daughter did, had 2 cases. She uses that as an excuse for why she doesn't listen. She loves me. For many of you, that whole dads and daughters thing, we know how that goes. Voila. So, other thing, we just talked about this. The biggest thing are the pseudostratified ciliated columnar epithelia. Those epithelial cells are wonderful. What do? They're able to continually take the particles and the materials that somehow evade the nose hairs, get trapped by them, and are trapped in the mucus, and basically move them towards your mouth so you can expel, swallow them, etc. They propel it upward out of the respiratory tract or forward or even into the mouth and forward. Okay, that's a major defense. And yes, there's other stuff that's there. These are we just did immune system and anatomy and physiology. I mean, it's an easy comment. These are your different defenses that are there. You have biological chemicals like complement. You have IgA. Well, you're in the middle of having an exam about this in anatomy and physiology. You know that's in secretions. We have macrophages that gobble it up. We have a variety of chemicals that can stimulate inflammation, defensins, antimicrobial proteins, blah, blah, da, 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 da. So they latch onto that bacterium, and out it goes. And that's what they look like when they're healthy. Tears. Which structure is attached to the ear? When it comes to normal biota, okay, upper respiratory, nasal hair, ciliary, mucus, coughing, sneezing, etc., secretory IgA, mucus here, but those alveolar macrophages and IgA are the big defenses there. I'll buy that. Nearly everything is normal when it comes to, and we did throat cultures. And if you got a chance, most of those throat cultures grew quite a bit. And you looked at them when you did the sampling in lab. We could have gone a little, maybe you stained them. I didn't have my group stain them that were there. But if you stain them, you get a potpourri of everything is in there. You get gram-positive, you get a preponderance of gram-positive cocci, staph, and strep, which are normal in respiratory. You get gram-positive rods called diphtheroids that are there. You get gram-negative cocci, like Neisseria species. Interesting, okay, Neisseria, this is, some people harbor Neisseria meningitis. The leading cause in adults of bacterial meningitis is this, Neisseria meningitis or Neisseria meningitidis, depending on however that's how they're spelling it here. And we have other kinds of, there's one called Moraxella, which is a gram-negative, which is sort of like a weaker cousin. We have gram-positive rods, which are diphtheroids. They look like diphtheria. I remember we saw some of those on some of the, when we did some of the environmental samples. They're everywhere. So you have everything, gram-positive, and you have gram-negative rods as well. The leading cause of bacterial meningitis in babies is something that we'll get into when we do respiratory diseases called Haemophilus influenza. I won't bother to spell it, it'll be coming. And H. flu, as it's commonly named, was named because they thought it was the source of the dreaded flu that I've talked about several times of 1918 and 1919, the so-called Spanish flu. Because they found that bacteria, and all they knew about were bacteria. You know, all the victims, and they're like, oh, this is called Haemophilus because it involved blood and did something that grew on blood agar and needed blood to grow. Influenza, okay, because they thought it was the cause of influenza. It is not, but it is one of the two most common causes of infants. And it used to be on the immunization schedule, Haemophilus influenza immunization. I do not know what the current immunization schedules are for children. So all of that, it's unclear what's in the lower respiratory tract. Here's Aspergillus, by the way, it's nasty. Okay, we unfortunately encounter it. Again, it's a matter of numbers. There's a lot of things in here that can cause disease. A lot of things that are in your nose and in your, like MRSA, in your throat. Streptococcus pneumonia, which is the leading cause of bacterial pneumonia, is normal in about a third to a half of us. All sorts of stuff is in there. Your defenses keep them in. So most of them are what they call commensals. They get along nicely with us. Even the lungs have it here. I'm glad I didn't have to write that down. Look at that. Strep pyogenes and H. flu, Haemophilus influenza. Those are together the two most common causes of ear infections. The most common causes of bacterial ear infections, bacterial sinus infections, and bacterial conjunctivitis that's not due to rubbing dirty fingers on little kids in their eyes. To that end, why amoxicillin became the drug of choice. Okay. Streptococcus pyogenes is effectively a relatively tame. Streptococcus is one of those organisms that typically sees a bottle of penicillin and dies. Oh my God, so you're going to use penicillin. Okay. So amoxicillin is an aminopenicillin. That aminopenicillin means it attacks gram-negatives. Both of this is relatively easy to kill gram-positive, but we're seeing more resistance these days. This is a relatively easy to kill gram-negative. So they came up with, the safest choice of people who are not allergic to penicillin was amoxicillin. If it turned out that this was a beta lactamase producer, then that's where augmentin came in. Again, the research was done here in Pittsburgh. It's very consistent. Okay. And down the road, you see that when the lungs are more compromised, let's say after a bad bout of flu, so say an elderly person, this is what works. Bacteria, it's not the flu won't kill them, bacterial pneumonia. So that's all. So the strep, not the strep pyogenes that they put, the strep throat. I misspoke. Strep pyogenes and strep throat strep, these are the two. Pardon me, I put my P's in that extent. And here's Neisseria ventitides and Staph aureus. And this is not unusual. People have candida, the yeast. The yeast we were using in lab for doing the hand washing, and what you guys are going to use next time was Saccharomyces cerevisiae. It's a baker's yeast or brewer's yeast. We like to use cerevisiae, cerveza, Dello, that kind of cerveza. Just saying. I know none of you would be involved in this instance. Okay. And so the candida is a common yeast that's, vaginal yeast infections are about candida albicans. Talk about thrush. So when I was on immunosuppressants, got some degree, unfortunately, of regularity, candida albicans. About a third to half was more of that. So it's bad. It's there in your mouth, and like a lot of these things, when your defenses are lacking for whatever reason, whether you're sick or where you're taking medicine that predisposes you, you get it. Yes.
Why do babies get it?
Probably because the defenses are not particularly well established just yet, and if they have to take any kind of medication, particularly if they get an ear infection, take antibiotics. That's it. It's very easy to treat. Now it's just, I know what they do with babies. Anybody, you can just have a lozenge in their mouth 4 or 5 times a day to take care of it. That's what they gave you. You just dissolve on your tongue, and you just make sure you let it dissolve. It works. Very efficient. You 3 to 5 days of doing it, you probably should do it for 10. Most of it's kind of, because to me it manifests itself as a sore throat. I go in to see my rheumatologist. He goes, got thrush. Your fault. You gave me that medicine. Treat me for free. But I don't want that, my insurance having to suffer that $250 bill from me saying hi to you. He didn't listen. Nice guy. So all of these things, the lung microbiome differs depending on a lot of factors. Certainly smokers versus non-smokers, diseases, performs the function of microbial. When I say microbial, they're the good guys. Reduce the chances of establishing themselves. And furthermore, with a question about babies, that probably has a role too. Because they had all the good guys aren't there. It's so fascinating. Okay, so I don't know what those names are. I know that's a Corynebacterium species, one of those diphtheroids. Commonly found, yes, Staph aureus is commonly found in the upper respiratory tract. There, here we go. Number 1 on the hit parade, pharyngitis, sore throat. You will see that throat. Those are tonsils. Those are inflamed tonsils. Can you make out the little white spots on them over there? Those are little pustules. That most of the time, that is a strep throat. In someone your age, what if the strep test is negative? What might it be? Correct. Mononucleosis. It's a funny differential. My stepdaughter had that her first year. She was like an alligator. Oh, those were enormous. And we went to the family doc and did a strep test. It was negative. I said, that's mono. It wasn't so bad that she just slowed her down a little bit. Not a whole lot. I did not know that was dying. I thought about other things over there, but those and very, very common. College students we see it all the time. Okay. But typically, it's red. It's inflamed. That's what you look for. That's, that whole, it's just, you see it all the time. And typically, remember, streptococcus has sort of a foul odor. It's not aerobic. It's in the category of a kind of anaerobe. And because of that, it effectively is almost fermenting material in the mouth. So you get kind of that, ooh. And I mean, back in our day, moms got the flashlight out and got whatever they could use as a tongue depressor. And if you had a red looking throat that looked like that and your breath smelled like you were out, you're drinking all night at age 5, that was the only time they hauled you to the doctor because they knew strep throats were dangerous. The problem with strep throat, I touched on it before, is immunological in nature. Your throat's going to get better. There's no permanent damage coming to that throat. The principal culprit is Streptococcus pyogenes, and we'll get over that in a second. Sore throats caused by bacteria are much more painful than those by viruses and more likely to be accompanied by this. Okay, fever, headache, nausea. In general, respiratory law, we have kind of the 1/3, 2/3 law. About 1/3 of upper respiratory infections are viral, about 2/3 are bacterial. The damage is done by the bacterial one, not so much by the viral ones, obviously with exceptions. But bacteria, viruses, most of it is mediated through your immune system. Inflammation, the typical signs we have when we have a bad cold or a sore throat. Okay? Bacteria secrete toxins, they damage things. Often the same viruses that cause the common cold, typically. Rhinoviruses, different kinds of coronaviruses, adenoviruses, mechanical irritation, all of those things are like it. The big problem is right here. Now, the Fusobacterium necrophorum is a gram-negative. That's not that common. This is number 1 on the hit parade. Group A, Streptococcus pyogenes. The other thing that it has is something that when you tried to look at it in lab, I didn't see a whole lot of positives. So its formal name. Group A, beta hemolytic. Yes, pyogenes means pus producer. Beta hemolytic is how we used to look at it. They do that plate, and if you were able to hold it up to the light and see through, it would have got beta hemolysis, means you totally gobble up the red cells. And then you looked at it in relationship to that. In my lab, we did that bacitration disc. Okay. Did you guys do the bacitration disc with that? Okay. You have to use it. He might have been using, there's 2 types of discs. We were running out of the ones. It's a very tiny dose. If you're using a typical 10 milligram bacitration, it's not accurate. And a lot of those discs got replaced. Group A, beta hemolytic Streptococcus pyogenes. Group A is credited with a lady named Rebecca Lansfield. She was then who discovered a series of carbohydrate markers on a lot of different streptococcal organisms. And that is the basis, everybody, of the rapid strep test. The one you can do at home. Testing for that carbohydrate marker. Basically, it's very similar to like the COVID things. And I think I do not know that you can get them without a prescription. Okay. But at the COVID test, we do the swab thing, you put in the liquid and stick in that little thing in X amount of time. Second line or the 2 lines show up, same. Okay. But it's not 100% accurate. Okay, so even if, and I'll tell you, even if the rapid test was negative, they're going to do throat culture and wait 24 to 48 hours to see if it is. So it's positive on the culture. The culture is the determining factor. For sure. If it's positive on that, there's not a whole lot of false positives. She discovered that, and it was brilliant. And it's very interesting. Maybe people in medicine softened, and it was quite a little while ago. But still, but now her name is associated. So it's one of those neat stories where a lady scientist actually got appropriate credit. Yes.
So what happens when you get it like back to back to back to back?
And you're taking your antibiotics correctly.
Then you might have, it strikes me, is it's an unusual strain that probably requires a more aggressive antibiotic, or there's something immunologically amiss. Because antibiotics only can do so much. It should be, theoretically, it shouldn't happen that frequently. So it makes you wonder if there's a flaw. Yes,
So this happened to me. I had strep back to back to back to back. And
Me
so I got my
too.
tonsils out, and now I'm fine.
so the tonsils were seeding it. See, your tonsils, even though your lymph nodes, did you have to have your tonsils out? Did you have the same problem?
Yeah, I had it 4 or 5 times.
Yeah, okay. It's hard to explain. What happens here is my kids had their tonsils out. My son and my oldest and my daughter, they had to, because they become a permanent source of infection. It's almost like they're corrupted. The infection is seeding it, growing all over. And it can send infections. My son, had an infection down in his abdomen. They thought it was appendicitis. I thought they were going to operate. The surgeon came in and said, I'm just not comfortable. It doesn't look right. He said, I think if he's had a lot of ear infections and strep throats, I wonder if the tonsils are bad. And son of a gun, we took him down here to Pioneer from living up in Oil City and saw a guy who has been there forever. He goes, yeah, your tonsils are a mess for the kid. They've got to come out. How they, and fine ever since. So that probably what it did to you. I mean, see, there's usually a reason for that type of stuff. Gram-positive coccus that grows in chains, does not have endospores, non-modal. We used to use that here as an unknown. Trouble is hard to grow. It just didn't grow well enough for the students to identify it. Capsules are a big player in this, as are slime layers. It's a facultative anaerobe, so it does not produce catalase. That's why it fails the bubble test. That's the big test between staph and strep. You see gram-positive cocci in the lab, we do the bubble test, the catalase test. If it's catalase positive, we're in the staph family. If it's catalase negative, we're in the strep family. Untreated infections or undertreated or inappropriately treated, I would edit that to say, are the big problems. And what happens is it's immunological in nature. Okay, scarlet fever, we see very little today because it was an erythrogenic toxin. That means it made the skin look red. Okay, and when someone had scarlet fever, if they had a milder appearance, they sometimes called it scarlatina. If they had a milder appearance, if they had a different appearance, it was mostly facial, it was called erysipelas. Why am I sensitive to that? My birth grandmother, my dad's mom, succumbed to erysipelas when he was 13 years old in 1927. Well, I didn't have any antibiotics. Okay? And so my grandfather married what in those days they called a maiden lady, someone who was about 30 and had married yet. It was very unusual. And the rest was history with that, because it was my dad, and he's 13, and his brother and sister, who were twins, were 4. And it was like, imagine my dad and my grandfather trying to raise it in some very, very difficult times that were there. So erythrogenic toxin it's what we call, and why it kills sometimes. Really, immunologically, it makes something called a super antigen. And we're going to hear more about them. You've probably heard of toxic shock syndrome. Okay. Heard of the flesh-eating bacteria, which happens to be a cousin of this streptococcal infection. Okay. Super antigens activate about 20% of your helper T cells. And those helper T cells go wild, producing massive amount of those cytokines. Helper T cells shoot out that interleukin-2, and the next thing you know, your body is having an out-of-bounds immunological response. Fatality rate, pretty big number. I mean, people, I knew people had this as kids. And it has some very odd effects because, again, are immunologic. One guy lost his hair. Somebody else lost their hearing. All of this was from scarlet fever. So if you didn't get a handle on it, you get some type of treatment on it, preferably antibiotics, okay? But that was the problem. Rheumatic fever. That's because antibodies for the streptococcus for certain strains, the antibodies, they don't know what the bacteria look like. They look for all those antigenic markers. The ones on the linings of heart, and particularly heart valves and joints, are attacked. Okay, an immunological cross reaction, not just heart muscle, but joint linings. Hence, the rheumatic comes from that. Okay, so there's a lot that's involved, and I'm going to continue on with it because you can't really know enough about this. So let's stop it here, and we'll pick up with strep pyogenes and virulence factors afterward. Thank you. I will get that dictation to you. I have to do another. I'm going to try to do another.